So at the 10 bank valve at the front of the machine here, I've got a pressure transducer now hooked up to the hose feeding supply oil from the pump into the 10 bank valve. And I've got a gauge here just showing that pressure. Seems to be some residual pressure sitting in there that's now bleeding off because I just had the machine running. I have another gauge here with a line running down to a transducer on this side of the 10 bank valve where we're picking up the pressure from the hose, the load sense signal hose that runs out of the valve here. There's actually a tap on this side of the 10 bank valve where we can check load sense signal. So right now that's sitting at 0. They're both sitting at 0 now that that one's bled down. I'm going to start the engine up and we're going to see what we've got on our two gauges. So I'm reading about 14 psi on my load sense signal. I'm not sure why that is. I would expect 0 when I'm not using any controls. But something's bleeding through a little bit in that valve and feeding a little bit of a signal out. At pump discharge, I've got 406. That would be our standby pressure. So standby is about 406, and our load sense signals, well, should be 0, but it's not. It's a little bit higher. So we're seeing standby pressure. Again, we've got a closed-centered directional control valve, and the pump is feeding it, and we're seeing that pressure standing by. I'm going to operate the side shift. So while I'm extending the cylinder, we can see the load sense signal on the left. Looks like about 2680, and then we could see the pump pressure in response to that on the gauge on the right, which I didn't record. But those two pressures are showing us again what our load sense signal being sent to the pump is, and then what the pump is sending in response to that. And we can also see that the side shift is not the most efficient function. It's taking a fair bit of pressure just to move the side shift with no load on it. But that is what it is. The pump is stroking up to provide the flow that's necessary to build a few hundred psi higher on the supply than what we're seeing on the load sense signal. Just going to try that going the other way. So I got about 1530 and about 1870. So we're getting about a 340 psi differential. So that's approximately what my margins setting is on the pump on this machine. I think the spec is 335 or maybe it's 350. So we're in the neighborhood of the specification. Of course, I'd want to be doing this with the oil up to operating temperature, and it isn't quite. I have been running it off and on a little bit today, but I really should warm the oil up more. But we're seeing about 340, 350, somewhere in that neighborhood pressure differential across the valve while the mold board is side shifting one end to the other. I'm not too concerned about the pressures if I'm looking at load sensing. I'm looking at what I'm interested in is the difference, or the delta P. And I don't actually have to use two of these gauges because there's an input 1 and an input 2, and these gauges are designed to work with load sensing systems, so they have a delta 1 minus 2 button. So I can put both readings into one gauge and watch the difference if I don't want to be concerned with the actual values. So as you recall, that was about a 10.5 second cycle time, one end to the other, and now we're seeing that it's a pressure differential of about 340, 350 psi. That's actually dictating that speed because that's what's causing the oil to flow across the control valve at the speed it is. So now I've hooked up both gauges into one. If I don't want to be doing the math all the time in my head, this tool will do it for me. So input 1, I've still got connected to the pump discharge pressure, feeding or the supply to the 10-bank valve. And then input 2, I've got connected to the load sense signal. If I got these backwards, it would just read a negative number for the difference. I'll start this up and we'll see what we get. We should have almost standby pressure on this gauge without any load sense signal. So I'm pretty much seeing standby minus the 14 or whatever is typically on. Yeah, I'm seeing, if I go to input 1, I'm getting my 406 standby, input 2, 14. If I read the difference, it should tell me the difference between those two. So it's showing me input 1 minus input 2. So now I'll watch that number while we operate the side shift. So I'm getting a pressure differential or a margin of about 320 while I'm side shifting to the right, and about 340, 350 or something while I'm side shifting to the left. And again, that's that 320, 350 pressure differential is what's giving me my 10.5 seconds of speed from end to end. I'm going to go to the pump. I'm going to put the implements on the ground, and then we'll go to the pump and we're going to make some adjustments to the load sense screw on the pump. And we'll see what difference that makes to the speed or the cycle time of this implement. And effectively all the implements, but we're just using side shift as our baseline.